Building a heart disease prediction model on AWS EC2 with C/CD pipeline. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction, Project Overview and Goals. Heart disease is a leading cause of death worldwide, making its early detection critical. In this project, we will build and deploy a machine learning model to predict heart disease. Our model will be hosted on an AWS EC2 instance, with a C/CD pipeline automating the deployment process. This project aims to provide a scalable, user-friendly prediction interface accessible via web application. Environment setup, creating a Git repository and virtual environment. Create a Git repository. Initialize a new Git repository on GitHub to manage your project code. Clone the repository to your local machine. Set up virtual environment. Install virtualenv if you haven't already. Pip install virtualenv. Create a virtual environment, virtualenv. Activate the virtual environment. On Windows, \venv \activate. On Mac OS Linux, source venv/bin/activate. Install necessary dependencies, pip install r-requirements.txt. MLflow integration with Dagshub, tracking experiments and logging results. Integrate MLflow with Dagshub to track your machine learning experiments and log results. Install MLflow and Dagshub. Pip install lmuflow Dagshub. Configure MLflow. Set up MLflow to log experiments to Dagshub by updating your configuration file. From Dagshub import dagshub logger. With dagshub logger as logger. lmlflow.log_param 1, value 1, lmlflow.log_metric 1, 0.5, track experiments. Use MLflow to track your experiments and log parameters, metrics, and models. Prediction pipeline design, stages of data processing and model building. Design a prediction pipeline consisting of the following stages. Data collection and cleaning. Collect data from relevant sources. Clean the data by handling missing values, outliers, and normalizing features. Feature engineering. Create new features from existing data to improve model performance. Model training. Split the data into training and testing sets. Train various machine learning models and evaluate their performance. Model selection and validation. Select the best performing model based on evaluation metrics. Validate the model using cross-validation techniques. Implementation details, configuration files and pipeline code structure. Configuration files. Create configuration files for different environments, development, testing, production. Store configuration settings include database connections, API keys, and model parameters. Pipeline code structure. Organize your code into data processing, feature engineering, model training, and evaluation modules. Use scripts for training and predicting to ensure reproducibility. GitHub Actions for C/CD, automating build and deployment processes. Set up GitHub Actions to automate the build and deployment process. Create a GitHub Actions workflow. Add a workflow YAML file to your repositories. GitHub/workflows directory. Define jobs for testing, building, and deploying the application. Name, C/CD pipeline. On, push. Jobs, build. Runs on, Ubuntu latest. Steps. Uses, actions/checkout at v2. Name, setup Python. Uses, actions/setup Python at v2. With Python version 3.8. Name, install dependencies. Run. Python mpip install upgrade pip. Pip install r-requirements.txt. Name, run tests. Run, pytest. Name, Deploy to AWS EC2. Run. SSHI your key.pem EC2 user at your EC2 instance Docker pull your Docker image and Docker run D your Docker container. UI development with Flask, designing a user-friendly prediction interface. Set up Flask. Install Flask, pip install Flask. Create a basic Flask app to serve the prediction model. From Flask import Flask, request, JSONify. App equals Flask _ name _ At app.root/predict, methods equals post-def predict. Data equals request.get _ JSON force equals true, prediction equals model.predict, data input, return JSONify prediction, prediction 0. If _name equals _main _ app.run debug equals true, develop the front end. Create HTML templates and static files for the user interface. Use Bootstrap or another front-end framework to enhance the UI. AWS configuration, creating IAM user, ECR repository, and EC2 instance. Create IAM user. Create an IAM user with permission to access ECR and EC2. Set up ECR repository. Create an ECR repository to store Docker images. Launch EC2 instance. Launch an EC2 instance to host your application. Configure security groups to allow necessary inbound and outbound traffic. Deployment on EC2, installing Docker, configuring security groups, and setting up runner. Install Docker. Install Docker on your EC2 instance. Sudo yum update y. Sudo Amazon Linux extras install Docker. Sudo service Docker start. Sudo usermod ag docker ec2 user. Configure security groups. Update security groups to allow HTTP/HTTPS traffic. Set up runner. Use GitHub Actions Runner to connect your EC2 instance to GitHub for automated deployments. GitHub secrets and final steps, connecting GitHub to EC2 and running the application. Set up GitHub secrets. Store sensitive information such as AWS credentials in GitHub secrets. Connect GitHub to EC2. Use GitHub Actions to connect to your EC2 instance and deploy the application. Run the application. Start the Flask application using Docker on your EC2 instance. Conclusion. By following this podcast, you will have successfully built and deployed a heart disease prediction model on AWS EC2 with a C/CD pipeline. This project leverages various tools and technologies to provide a robust and scalable solution for heart disease prediction. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.